In Antarctica's endless white, a shocking sight appears, a 5-story cascade of deep red pouring from a glacier. This is Blood Falls, a surreal natural wonder that looks like a wound bleeding onto the ice. Against the stark landscape, the crimson waterfall is a haunting contrast, defying the Antarctic cold. Blood Falls is a scientific mystery, daring us to uncover the secrets hidden beneath the ice. Blood Falls was first discovered in 1911 by British explorer Thomas Griffith Taylor. Imagine trekking for months through endless white, only to find a glacier that appears to bleed. Early explorers, lacking modern tools, guessed the red color came from algae, tiny organisms known to tint snow pink or red. This theory stuck for decades, painting Blood Falls as a biological curiosity. But as science advanced, researchers began to question the algae explanation. Modern analysis of the water found almost no red algae. Certainly not enough to explain the intense color. The mystery deepened. If not algae, then what? Scientists realized the answer lay not on the surface, but deep beneath the glacier. The truth would upend old theories and reveal a hidden world. Blood Falls was more than a curiosity. It was a gateway to a profound scientific discovery. The real explanation was waiting, locked in the ice, and it would change everything we thought we knew. The secret of Blood Falls is chemical, not biological. The water is loaded with iron, trapped beneath the glacier for millions of years. When this iron-rich, salty water finally reaches the surface, it meets oxygen for the first time in ages. The iron reacts instantly, turning to rust, giving the water its dramatic blood-red color. Blood Falls is, quite literally, a waterfall of rust. This discovery overturned the algae theory and shifted focus to the glacier's unique geology. The water is a time capsule, sealed off from the world, carrying the chemical signature of an ancient Earth. Without oxygen below, the iron stayed dissolved and invisible. Only when exposed to air does the transformation, and the spectacle, occur. This constant chemical reaction explains the waterfall's steady flow and color, but it raised a new question. Where did this strange iron-filled water come from? The answer would lead scientists deep beneath the ice, to a world untouched by sunlight, and there, they found something even more extraordinary. Beneath Taylor Glacier lies a small, ancient lake, trapped millions of years ago as the glacier advanced. This subglacial lake is not vast, but it's incredibly salty, 3 to 4 times saltier than the ocean. The salt keeps the water liquid, even at temperatures far below freezing. Buried under 400 meters of ice, the lake is in total darkness and completely cut off from the atmosphere. Any oxygen was consumed long ago, leaving an anoxic, high-pressure, freezing environment. It's one of the most extreme places for life on Earth. The water emerging at Blood Falls is a sample from this lost world, a message from deep time. Each drop carries clues about ancient Earth, preserved in isolation. The discovery of this hidden lake transformed Blood Falls into a vital natural laboratory. It offers a rare glimpse into environments that may exist elsewhere in the solar system. Here, scientists can study a world untouched for millions of years. And what they found inside changed our understanding of life itself. Even in this darkness, life found a way. Scientists discovered that the subglacial lake is teeming with microscopic life, bacteria and archaea thriving in total darkness. These microbes survive without sunlight, using chemosynthesis to create energy from chemicals in the water. They breathe sulfate and metabolize iron, living off the rocks and minerals beneath the glacier. This ecosystem has been isolated for millions of years, offering a glimpse into ancient life on Earth. It's a living time capsule, showing how life can persist in the harshest conditions. These microbes may resemble those that survived snowball Earth events, when the planet was almost entirely frozen. Their resilience is astonishing. They endure extreme cold, pressure, darkness, and a toxic, salty environment. The existence of this thriving community forces us to rethink what life needs to survive. Blood Falls proves that life can adapt to places we once thought impossible. It expands our imagination about where life might exist, on Earth and beyond. In the most desolate corners, life endures. The lesson is clear: life is far more tenacious than we ever believed, and its story doesn't end here. Blood Falls is more than a scientific marvel. It's a model for life beyond Earth. The conditions beneath Taylor Glacier mirror those suspected on Mars or the icy moons Europa and Enceladus. If microbes can thrive in Antarctica's dark, salty, iron-rich lake, why not elsewhere in the solar system? Blood Falls helps scientists develop tools and strategies for searching for life on other worlds. It's a testing ground for technology that could one day probe alien oceans. The lessons learned here guide the search for extraterrestrial life. Blood Falls reminds us that even the most forbidding places can harbor secrets. It challenges us to look at barren planets not as dead, but as places of possibility. If life can survive sealed beneath Antarctic ice, it might be waiting elsewhere in the universe. The Bleeding Glacier is a beacon of hope, a reminder that life finds a way, even in the coldest darkness, and the search for life has only just begun.